Distinguished attendees, I extend my sincere greetings. In this opportunity, I am going to present the project titled Chagas disease and analysis with temporal feature extraction, permutation entropy, and stratification with heart risk by a deep learning model. Chagas disease, once rural, is now predominantly urban, affecting 70 million people, posing a public health threat. It has acute and chronic phases, often involving silent cardiac issues. As a result, the establishment of early markers is crucial. To achieve this, the present study proposes the analysis of RR data through permutation entropy and feature extraction. This study used the ECG database from the Institute of Tropical Medicine at the Central University of Venezuela. 3 groups were analyzed: 83 volunteers, control group, 102 with Chagas but no heart issues, CH1 group, and 107 with mild-moderate heart failure, CH2 group. Data comes from 24-hour ECG recordings with RR intervals in 288 5-minute frames. We use permutation entropy to assess the complexity of each patient's RR data, a concept introduced by Pant and Pompey to identify patterns in time series data. We computed this entropy for each RR interval row, resulting in a 288 value vector per patient. Using the time series feature extraction library, we extracted 390 RR data features and compared these ones and permutation entropy values, retaining those with a p-value below 0.05. Finally, we tripled the dataset by adding Gaussian noise at 0.02 factor. Prior to inputting the data into the network, a dimensionality reduction process was performed using principal component analysis, reducing the input dimension to 150. The model has one input layer with 20 neurons, an activation function sigmoid, 3 hidden layers of 15, 9, and 7 neurons with activation function GELU, and finally an output layer with 3 neurons and softmax as activation function. In the results, we can see that loss and categorical accuracy graphs display the same trend during both training and validation. The only minor observation is a slight plateau in the validation curve at slightly elevated values. Nevertheless, as these values are not significantly high, they don't pose a concern. The classification results are impressive, with a 98% total accuracy. In the control group, precision, recall, and F1 score all achieved 99%. For the CH1 group, precision reached 97%, recall stood at 96%, and the F1 score was 97%. In the CH2 group, precision hit 97%, recall reached 99%, and the F1 score attained 98%. This study validates the use of permutation entropy in RR data for distinguishing Chagas disease patients. Additionally, employing feature extraction and data augmentation enhances network performance, elevating classification accuracy from 91% to 98% compared to previous research carried out.